The function f of x is given by f of x is 3x cubed minus 1 over x cubed plus 1 for values of x between 0 and 3. We want to show that f dash x can be written in this form and k is a constant to be determined. So if we look at this expression up here, it's a quotient. And so what I'm going to do, I'm going to write u is equal to 3x cubed minus 1 and v is x cubed plus 1. And then du dx would be 9x squared and dv dx will be 3x squared. So f dashed x is going to be v du dx. So that's 9x squared x cubed plus 1. Take away u dv dx, so that's going to be 3x squared, 3x cubed take 1, all over v squared. So that's x cubed plus 1 squared. So we've got the right denominator, which is a good sign. So expanding out on the top here, we're going to get 9x to the 5 plus 9x squared. Then we'll get take away 9x to the 5 plus 3x squared all over x cubed plus 1 squared. And we can see those 9x to the 5s are going to cancel out. So we'll end up with 12x squared over x cubed plus 1 squared. And that means that k is equal to 12. So what we want to do now is find the integral of this expression, which note is like this expression but without the 12, and hence evaluate this. So let's do this integral first. Well, what we know is that the integral of 12x squared over x cubed plus 1 squared has got to be 3x cubed minus 1 over x cubed plus 1 plus a constant. And we know that because the integration and differentiation are reverse processes. So if we integrate that, we're going to get what we differentiated to get it. And therefore the integral of x squared over x cubed plus 1 squared would be 3x cubed take 1 over 12 x cubed plus 1 plus a constant. So now the definite integral based on that, so the integral from 1 to 2 of x squared over x cubed plus 1 squared is going to be 3x cubed take away 1 over 12 x cubed plus 1 to be evaluated from 1 to 2. So the top bracket is going to give me, so 2 cubed is 8 times 3 is 24. So we've got 23 over 8 and 1, 9, so 12 times 9. Take away, put 1 in here, and we're going to end up with 2 over 12 times 2. And I think we can just calculate that. So what do we got? 23 over 12 times 9. Take away 2 over 24. That gives us 7 over 54. Okay, there's another part of this. Find the inverse function for x, stating its domain. So f of x is 3x cubed minus 1 over x cubed plus 1. So f of x is 3x cubed minus 1 over x cubed plus 1. Let's just check that that's correct. So 3x cubed minus 1 over x cubed plus 1. Okay, so we can find the function easily enough. So we've got to let y be equal to 3x cubed minus 1 over x cubed plus 1. And then interchange the x and the y. So we've got 3y cubed take away 1 over y cubed plus 1. And then we want to make y the subject. So bring this one up over here, and we've got x y cubed plus 1 equals 3y cubed take 1. So x y cubed plus x is 3y cubed take 1. Bring everything that's got a y to one side. So we've got xy cubed minus 3y cubed is going to be negative 1 take x if the x comes over here. So take out the y cubed, and I've got x minus 3 is going to be negative 1 plus x. So y cubed would be negative 1 plus x over x take 3. You could leave it there, but if I swap the 3 and the x here, I can get rid of that nasty negative. It'll just look a bit nicer. So that's going to be that, and therefore y is going to be the cube root of 1 plus x over 3 minus x. So the inverse function is going to be the cube root of 1 plus x over 3 minus x. Now the domain is actually going to be the hard part of this one, I think. So it's got to be the range of this original function, but note the definition of the domain for this original function. So we've also differentiated this, and we can see that the only turning point is at 0. So in actual fact, to work out the range for this, we can just use these endpoints. So here's our function up here. So f of 0 would be negative 1, and f of 3 would be 3 cubed 27, so 3 is 81, take away 1 is 80, over 28, which is 40 over 14, which is 20 over 7, which is going to be 2 6/7. So that's the range in between those two for the original function, and therefore the domain of the inverse function is going to be that x is greater than negative 1, less than 2 6/7. Let's just go and check that inequality again. Was it strictly between? No, it was equal to as well. And so I think that these are less than or equal to.